Hi, in this video I will solve some questions about definite integral as a limit of Riemann sum. If you want to understand the idea of this equality, you can watch the last video. Okay, let's remember the definition. From a to b, definite integral of f of x dx equals to limit n goes to infinity sigma notation from 1 to n f of a plus delta x times I delta x. What is a? A is a initial x value. A is actually x0, or this is a lower bound. So this is a lower bound. I have an index here and delta x. Dx and delta x are similar, and I have another delta x here. To understand which region represent x value, you can check delta x times I. So a plus delta x times I will give us x value. And delta x equals to b minus a over n. It means that if a is 3 and delta x is 5, then b will be 8. Okay, let's start to solve some examples. Here I have a definite integral, and I will convert this definite integral into limit of Riemann sum. Okay, this is general, so I will write here n goes to infinity, sigma notation, I 1 to n, and I need to check delta x now. What is delta x? Delta x is 6 minus 4 over n, so delta x is 2 over n. And what is the lower bound? Lower bound is important for us. Lower bound is 4. So I will write x value as 4 plus 2 over n times I. So 3 times 3 is a coefficient, so I have to write 3. Instead of x, I will write 4 plus 2 over n times I. Plus 5 is a constant value. After that, instead of dx, you will write delta x. What is delta x? 2 over n. And this will be the limit of Riemann sum. Okay, the other one. Let's start with the lower bound. Lower bound is 5. And delta x is 9 minus 5 over n, so delta x is 4 over n. And in order to write x, we will start with lower bound 5 plus 4 over n times I. Let's start it. Limit n goes to infinity, sigma notation from I to n. 8 is a constant value, 8 minus 2 is a coefficient. Instead of x, you will write 5 plus 4 over n times I. And instead of dx, you will write delta x is 4 over n. Okay, we completed the first two examples. In the third one, we will do the other way around. We have limit n goes to infinity and Riemann sum. So we will construct definite integral. You can start with delta x. This dx is delta x, 6 over n, and we have here delta x again. So delta x is 6 over n. And you should understand which part is x. You can use delta x times I. So this part is x. This is why you can check the initial condition or lower bound. Lower bound will be minus 2. then our integral will start with minus 2. Since delta x is 6, to find upper bound, you can directly add delta x. Minus 2 plus 6 will be 4. And minus 2 plus 6I over n is x, so I will write x here. We have a cube, x cube, times 6 over n is delta x, it means dx. That's it. And the last example, again start with delta x. Delta x is 4 over n. We have the delta x value again. Delta x is 4 over n. We should understand the x part. X part is 4i over n. X is 4i over n. And we don't have any constant value. Constant value is 0. It means lower bound is 0. This is lower bound. So, integral will start with 0. Since delta x is 4 over n, the upper bound will be 4. 6 is a coefficient. 4i over n is x value, x squared, and minus 2 is constant value. You will write dx instead of 4 over n. This is the end of the video. Thank you for listening.